In this lecture, we will learn what a console is and the role that it plays in computer science. In any computer program that you use to write code, there will be a console. The console is responsible for displaying messages, warnings, and errors to the developer. Also note that the console is not seen by the end user of the application, just the developer using the IDE. There are two types of consoles in Python. One is a shell where you can execute commands. The other is a panel where you can view program output, for example, where you can use the print function. This video will focus on that console. The first thing we will do is to use the print function in our file. For example, we will print out the string ABC. Then we will run the code. You will notice that a panel titled Run will appear along the bottom of the screen and display the program output ABC. When I refer to the Python console in this course, I am referring to this panel. There is also a Python console tab that opens up an environment where we can type in commands, but that is separate. There are some buttons along the side of the console that we should be familiar with. The green triangle lets us run the code. The square lets us stop running the code. The button underneath this lets us restore the default layout. Then comes a button to pin the tab in place. We can use the arrows to move up and down in the stack trace. We can use the soft wrap button to enable soft wrap functionality. Scroll lets us immediately jump to the end of the console output. Print allows us to print the console output from a printer if our computer is hooked up to one. The trash can is the clear all button. Clicking it will clear all of the output showing on the console. In the next lecture, we will learn about conditional statements. In this lecture, we will learn about conditional statements in Python. There are times when we are programming when we need to branch logic based on a condition. For example, if the condition is true, we perform some action. Else, we perform a different action. A control structure or conditional statement lets us control the order of execution of the statements in a program. Essentially, a conditional statement allows the computer to decide which possibility to execute out of one or more possibilities. Which possibility is executed depends on the value of a Boolean variable. The first type of conditional statements that we will learn about are if, elif, and else. You may be familiar with some of these if you've worked with other programming languages before. The syntax for an if statement is first the word if, then the expression, and then a colon. On the line beneath the if statement, the code is indented. For example, this if statement will check if 1 is less than 2. If that is the case, it will print 1 is less than 2. When we run the code, you will notice that 1 is less than 2 was printed to the console. This is because 1 is less than 2. Since the condition is true, the code inside of or indented underneath the if statement is run. Notice if we flip the sign around, making the condition 1 is greater than 2, and then run the code, nothing was printed this time. When the condition of an if statement is false, the code indented underneath it is not run. Currently, our program is limited to just one branch of logic. Either the line will be printed or not, depending on if the condition of the if statement is true or false. What if we wanted to have more branching logic in our code? That is where a conditional statement like elif comes in handy. If you've worked with another programming language like Java or C#, you are probably familiar with the else if statement. Elif is Python's version of that statement and works the same exact way. In the event that the if statement above it is false, the elif statement will be checked. Note that any elif statements need to come below if statements. When we run the code, notice that 1 is less than 2 was printed to the console. This means that the condition for our if statement evaluated to false, but the condition for our elif statement evaluated to true. When I say evaluated, I mean that the expression 1 greater than 2 is checked by the computer program. It is converted into a Boolean value that represents whether or not it is factual. Since mathematically 1 is not greater than 2, it evaluates to a Boolean value of false. The same goes for the condition of our elif statement. Since 1 is less than 2, it evaluates to true. Note that we can have as many elif statements as we like underneath the other if and elif statements. Let's look at an example that supports more than just these two possibilities. For this example, we will start out with a variable x and give it an initial value of 6. Then we will have an if statement that checks if x is equal to 0. Note that to check if two things are equal in Python, we use the double equal sign. If x is equal to 0, we will print x is 0 to the console. Then comes our first elif statement. If x is less than 5, we print out x is less than 5 to the console. Under that will come another elif statement that checks if x is greater than 5. If so, we will print out x is greater than 5 to the console. Since x is 6, we know that this elif statement will be hit, and the statement x is greater than 5 will be printed to the console. But let's run our code just to double check. Yup, we were right. The second elif statement in our program was hit. Sometimes an if statement and all of the other elif statements beneath it won't execute if all of their conditions are false. In this case, it is handy to use an else statement, which will execute if the if and elif statements above it are false. By using else, you guarantee that one conditional statement will be hit. For example, say we have our variable x set to a value of 4. Then we check if x equals 1. If so, we will print x is 1 to the console. After that, we will check if x is 2, using an elif statement. If it is, we will print x is 2 to the console. Then we will check if x is 3, and if so, print x is 3 to the console. Finally comes an else statement. In the event that the first 3 statements above it were hit, we will print x is greater than 3 to the console. One key point to note is that x could be negative or 0, since in Python, an integer can be a positive number, negative number, or 0. But for the purposes of simplifying this example, let's pretend that x had to be positive. When we run the code, you will notice that the else statement was hit, and x is greater than 3 was printed to the console. Please note that there are other conditional expressions, such as Python's ternary operator, but these will be examined in later videos in the course. The idea of this video was to get you some basic exposure to control flow statements, with the basic ones being if, elif, and else. In the next lecture, we will learn about loops in Python. In this lecture, we will learn about loops in Python. A loop executes a piece of code repeatedly until a condition is fulfilled. Many of the programs you write will involve loops. Loops are useful if you want to execute code over and over, but only have to write the same code once. There are 2 main types of loops in Python: for loops and while loops. A for loop goes through items until the provided length is reached. We call this iterating over the elements. A while loop, on the other hand, executes until a specified condition is met. Here is a very basic example of a for loop in Python. We will start out with a list of strings, A, B, and C. Don't worry about lists for now. Just know that they hold multiple values. A list is just a special type of variable, but instead of holding one value, it can store many values. Then we will type 4x in letters, and then a colon. Underneath this, we will indent the line and type print x. When we run the code, you will notice that each item in the list, A, B, and C, were printed to the console. Note that aside from lists and other container data structures, we can also loop through a string. A string is an iterable sequence of characters. To achieve the same effect as we did with our list, we could just do the following. For x in the string ABC, print x. When we run the code, you will notice that A, B, and C were printed to the console. That is a look at for loops in Python. The other type of loop that Python supports is the while loop. A while loop will execute its body of code as long as its condition evaluates to true. We will start out with a variable num, set equal to a value of 3. Then we will use a while loop with a condition of num greater than 0. Inside of the while loop, we will print loading to the console. Then we will decrement the num variable. This just means that we subtract 1 from the num variable. So the program subtracts 1 and then assigns the decreased number in place of the value that num was holding. When we run the code, you will notice that loading was printed out 3 times. Why is this? Well, on the first iteration, num is 3, and 3 is greater than 0, so that code is executed. Num then becomes 2, which is also greater than 0, so the code gets executed. Then num becomes 1, so the code is executed again. Finally, num is 0, which is not greater than 0, so the code inside of the while loop is not executed. In summary, you will frequently use loops in your programs. A for loop goes through items in an ordered collection. A while loop runs over and over while a condition is true. In the next lecture, we will learn about variable scope. In this lecture, we will learn about variable scope in Python. If you're new to programming, you might be surprised to learn that not every variable you create in a program will always exist during the lifetime of the program. In other words, some variables are accessible only at certain points in the program, depending on where they are created. This is what is known as variable scope. Scope just means that a variable can only be accessed within the region or part of the code where it is created. When we have a variable up at the top of our program, we call that variable a global variable. Anywhere else in the code we can use this variable. Then let's say we have a function named function1, and inside of this function we have a variable y that we set equal to a value of 3. Variables that are created inside of a function are local to that function. What does this mean? Well, we can reference this variable y inside of our function1 function, but not outside of it. Let's go outside of this function and create a variable z, which we will set equal to x plus y. Then we will run the code. As you will notice, we get a name error. Specifically, we get the error message that the name y is not defined. This is because we created the variable y inside of function1, so outside of this function there is no definition of the variable y. To fix this, we can actually use Python's global keyword. We will break up the creation of the y variable into 2 steps. One will be a line using the global keyword and creating the variable y. The other will be where we assign the variable y to a value of 3. Then we need to call function1 above where we create the variable z, so that the variable y gets created when that function is run. After we create z and assign it to x plus y, we will print it out using Python's print function. When we run the code, you will notice that it works and that the error is no longer thrown. In the PyCharm console, you will notice that 8 was printed, since x is 5 and y is 3, and we set z equal to x plus y, which is 5 plus 3. That is a basic look at how variable scope works in Python. In the next lecture, we will learn about modules. In this lecture, we will learn about modules. A module is simply a file that contains some Python code. Whenever we add an import statement to the top of our program, we are importing a Python module. For example, to import Python's math module, we can add import math at the top of our program. That gives us access to the different functions that are contained in Python's math module. For example, we can use the ceil function to round up a float to the nearest integer. We can use Python's print function and pass in math.ceil and then pass in 1.4. When we run the code, you will notice that 2 was printed. Now, when we use import to import a module, all of the code from that module is imported into our program. Imagine working with a program that uses code from 100 different modules. That can start to make things harder to manage. Sometimes, we just need to import 1 or 2 specific things from a module. In that case, we can use the from module import item syntax. For example, we can say from math import ceil. Then we don't need to say math.ceil in the print function. We can change that to just be ceil. Now when we run the code, you will notice that 2 is again output to the console. If we want to import everything from a module, but use the from keyword, then we could do so using the asterisk character. Also known as the wildcard, the asterisk is useful for syntax where we want to grab everything from a module. In the example of the math module, we would type from math import asterisk at the top of the program. In the next lecture, we will learn about comments. In this lecture, we will learn about comments. In Python, a comment is preceded by the pound symbol. Comments can come after a line of code, on the same line as it, or they can go on their own line. Both ways are valid. Python doesn't officially support multi-line comments, but we can use the triple quoted string to create a multi-line block of text that the computer will ignore when the program is executed. In the next lecture, we will learn about the basics of working with functions in Python.